Okay, welcome everyone to our July 8th edition of the Rutgers Ornamental IPM program webinar. My name is Bill Errickson. I am the agriculture agent for Rutgers Cooperative Extension in Monmouth County. I'm also joined by our IPM program associate, Steve Rettke, and our agriculture agent, Tim Waller from Cumberland County, and our IPM program support staff, Erin and Quinn. And so we're going to be talking about some insects and disease and cultural practices today. We're also going to be covering some materials. So a disclaimer on the bottom, make sure you always follow the label and the proper PPE guidelines, and that these recommendations are made for commercial applicators in the state of New Jersey. If you're working in a landscape setting, you may have different regulations, or if you're working from a different state. So just make sure that you're always following the proper regulations. So we've got some good topics to talk about today. We've got some beneficials to the minute pirate bug, and then several insect pests we're going to cover, some plant leaf galls. We're going to look at root disease symptoms and how they appear in the summer. And then we're going to go over some technical topics on sprayer calibration and nozzle selection. So really important skills to have in the toolbox. If we look in the bottom of the screen, we're going to see our current growing degree days. We've been heating up a lot recently. South Jersey is already up above 1,600 growing degree days. Central New Jersey is in the 1,500 range, and we're still around 1,300 in northern New Jersey. So we're seeing quite a fair bit of progress in terms of insect development. And so we're going to focus today on things that we're seeing, within this 2-week time period for these growing degree days. If you haven't signed up yet for our plant and pest advisory, it's the best place to find updates. You can also find, everything we've covered so far for the season and from previous years on the Plant and Pest Advisory. So it's a searchable website. And if you sign up, you can also get alerts sent right to your inbox. And then check out our new website. So all of these webinars are sent out, usually within 24 hours to program participants, and then they get posted live to the website along with the downloadable printable slides. All right, so our first insect we're going to look at today is the minute pirate bug. And this is a beneficial insect, and it is truly minute. So even the adults, the full-size adults, are less than 0.2 inches in length. And of the insects that I'm going to be talking about today, I'm going to talk about 4 different insects, and they're all from 4 different orders of insects. So that's kind of interesting. Now, the minute pirate bug, this is a true bug. Okay, so this is the Hemiptera order. And so they have piercing and sucking mouth parts, right? And so they're going to use this mouth part to actually feed on prey pests. So they can feed on mites, thrips, whiteflies, other small insects, because remember, those are very small. The adults are going to overwinter in dead leaves, so leaf litter, which can be good to keep around in the landscape, bark, trees. So they overwinter in our area, and there are several generations throughout the summer. So they're active, and it's a pretty quick life cycle. But they can actually bite and feed on humans. So that's something to watch out for, or it could be a reason to keep more flowers around to have nectar sources so they don't start to feed on us. So this is what they look like. Here's the adult. You can see that distinct pattern on the back, and they can actually function as pollinators in the landscape too, just having that ecological role. We see the second instar nymph up top, and they actually have that yellow color. So before they turn into adults, they're actually going to look a little bit different, and they're going to have that yellowish orange gold kind of color to them. And on the right, that's a great picture. You can see the adult with that piercing and sucking mouth part feeding on the whitefly larva there. Okay, so we saw that, they feed on nectar, and so keeping diverse species that are blooming throughout the season can help to encourage them in the landscape. Allowing leaf litter to be present in the fall will allow them to overwinter, but always remember if that leaf litter has any disease or leaf spot or anything like that, you do want to get that out for sanitation purposes. But that's a spot that they can overwinter and other beneficials as well. If you have small populations of pests, you have soft-bodied pests, aphids, whitefly larvae, it's okay to leave them if they're not becoming an economic concern. So if they don't hit that threshold level, you can allow them to exist on the plants, and that can encourage some of these beneficials to have that food source. And just be aware of your spray program, that can impact these beneficials as well. So follow the label instructions, especially if you're using any kind of systemic material. You got to follow the label to reduce the impacts on blooms so it doesn't get into the pollen and the nectar and negatively impact these non-target species. Okay, so our second insect that we're going to talk about, this is a pest. This is the two-banded Japanese weevil, and this is a beetle. So this is our second order of insects. This is Coleoptera. These are pretty small too, 3/16 of an inch, about under a quarter of an inch, and they're actually flightless beetles, so they can't fly. And you'll see those two bands on their back, and that's how it gets its name, the two-banded Japanese weevil. Those two dark bands. And then they have the grooves on their wing covers, but the wings are fused. So again, they can't fly. So what's going to happen is that the adults are going to feed on the leaves, and we'll see some of that feeding damage in the next slide. And then they're going to lay their eggs, and the larvae are going to burrow into the soil, and the larvae can feed on the roots of plants. So later in the season, there can be problems with the larvae feeding on the roots, so we may not see that damage above ground. But right now, in South Jersey in particular, you may be starting to see activation of the adults and some of that feeding damage. There's only one generation per year, and the adults are going to cause this kind of deep leaf notching, especially on the lower leaves, and we'll take a look at that. They're going to feed during the day, and one thing that's interesting that we can use for monitoring and control of the two-banded Japanese weevil is if we disturb them. So if you brush your hand over the leaves or you knock on the leaves, they'll fall to the ground under the leaves. And so we can use that as either monitoring or to capture them and control them that way. So that's an interesting feature of this insect. And they're going to feed on many of our ornamental shrubs, privets, azalea, rhododendron, mountain laurel, euonymus, so common generalist pest. And there you can see that deep leaf notching. So they're chewing these, irregular along the leaf margins is where it's going to start. See that on the left and the right side of the screen. And we can see two pictures of the adults for identification. And you see those dark bands on the back and the grooves along the wing coverings. Now it's interesting, their eggs, they'll usually lay their eggs kind of inside of a leaf, and it curls over. So like a blade of grass, and it might curl over, and then the eggs will be laid inside of that. So it can be kind of hard to find the eggs if they are present. Okay, so there are many natural predators that can feed on them, but then we talked about that, kind of unique characteristic where the adults are going to drop to the ground if we disturb them. So if you shake the leaves, or you're just going through, you're monitoring, you're checking, and you see these weevils drop out of the plants, that's a good way to know that they may be present in the nursery or in the landscape. And so you can either, if you want to use that for monitoring, that's how you can find out that they're there. But if you want to actually use that as control, you can put something down under the plants, like a sheet or a tarp, knock them all off. They'll drop right off the plants. You can gather them up and dispose of them. Contact insecticides will work, pyrethroids in particular, because there has been research showing that they are resistant to carbaryl. So pyrethroids would be, if we're going for kind of a broad spectrum contact, that would be one to choose, but also remember that that can harm non-target species as well. Some of our systemics can also be effective, and then we have our biorationals, azadirachtin in particular. This can be a good one to help with control. So our third order of insect that we're going to talk about today is Lepidoptera, so Nantucket pine tip moth. So these are our moths, and these are going to have 2 generations per year in New Jersey. So the first generation adults emerged in April, and they laid their eggs in the tips of new growth. And these are going to affect pines and mostly 2 and 3 needle pine species. So in particular, like loblolly and shortleaf pines, those are really susceptible, and some of our other ornamental pines as well. So the adults, first generation came out earlier in the spring, laid its eggs in the tips of the new growth, and now the second generation of larvae are going to start to hatch around now. Probably already starting to see them in South Jersey, going to see them in central New Jersey very soon. And they're going to feed on the needles and then enter the buds and the stems. So we're going to see this damage. I'll show you some pictures in the tips of our pine trees. So pines less than 6 feet tall and full sun are going to show the most damage. So field nurseries, Christmas tree farms, this can become a big problem if it's not kept under control. And we're going to see that dieback happening on the tips. So they actually overwinter as pupa, and we see that in the top left there. And so that's what the first generation adults are going to emerge from. The pupa are going to be in the tips, and they're going to emerge in the spring and then come out to the second generation. Larvae are coming out now. There are pheromone traps that we can use to catch the moths for monitoring. But then another way that we can monitor them too is if you know that you have pupa in the tip, you can cut that tip, prune it out of the tree, and then put it in a plastic bag and put it into a shady area and allow it to develop. And when the adult hatches out, then you know there's activity. Then you wait another 10 days or so later, and then all the other adults you can imagine have hatched out, and then you can treat from there. So we can use that knowledge of the life cycle for monitoring and treatment also. But we see that dieback of the branch tips. It's that yellowing and then brown, the discoloration in the tips of our pine trees. And if you look a little bit closer, you can see the caterpillar, that larva, feeding, and that feeding damage and the frass right at the tips. So that's kind of what we're looking for when we're scouting and monitoring for them. There are many natural predators of this insect, and so they can be problems in forests too, and a lot of the times they won't be treating them in forests because of the natural predators, but it's monitoring it and seeing if the natural predators are not keeping this in check. You may have to, take control in a season, to get it into a, reasonable economic threshold level. And it might not be something that you have to do all the time, but if it starts to be a problem, you got to get it under control. So the pheromone traps can detect when the initial emergence of the males come out, or we can, collect those tips that have pupa in them and hatch them out ourselves. And then you want to wait, 10 to 14 days before applying the control so that more of them hatch out and it's more effective. So in a small setting, or it's more labor intensive, but it's effective. If you have dying tips, you can prune them out by hand, reducing plant stress. That helps also. And then planting other resistant species. So like our eastern white pine and longleaf pines, those are not going to be affected by Nantucket pine tip moth. It's more the 2 and 3 needle pines. So our spinosins can be effective as contact materials, biorational materials. We have some insect growth regulators that are also effective. And then BT, Bacillus thuringiensis, can work on these as well, because remember, these are moths, so BT can work on those, on Lepidoptera. Our neonics and those can work, but they have to be applied ahead of time to allow that material to get into the plants. And then we've got some organophosphates and avermectins also for other systemic options. Okay, our fourth insect and our fourth order of insects for today is the dogwood sawfly. And these are actually wasps. So they're Hymenoptera. And so totally different order of insect. They might look similar to the caterpillars of, of a moth, of a Lepidoptera, but totally different order, so different controls. And BT would not work on this particular insect. So what we're looking at here, this is the larval stage. The adults are going to be these, shiny little black wasps, and they come out May through July. And then it's actually going to be the larval stage that is causing the feeding damage. I'll show you that damage on the leaves. So as the name would suggest, these are going to affect dogwood sawfly. They've got one generation per year, and they're kind of distinct. And the maturing larvae have this white powdery covering on their bodies. And I'll show you some good pictures of that also. Okay, so this is what they look like, and you can see that white powdery coating, and it's getting on the leaves. You can see it on the backs of the insects, and then you can see that feeding damage on the leaves. So I've got several different life stages here, different images of how the damage can look. But if you see that, that white powdery coating, that's distinctive that we're looking at a dogwood sawfly. But remember, they're not Lepidoptera, they're not moths, not the caterpillars of moths. So our treatment options are going to be different. There are natural predators, birds, spiders, predatory stink bugs, wasps that can help with our control. They can be pruned out or handpicked if their populations are low and you've got the labor to do it. So encouraging natural predators, reducing stress, encouraging airflow, all of our good cultural management practices will help with this. For contacts, the carbamates and the pyrethroids, but pyrethroids are going to be more broad spectrum, so keep that in mind. The neonics and organophosphates will also work as systemics if these become a big problem. And then some of our biorationals, the spinosins, horticultural oils and soaps as a directin, acetamiprid, all of these will be effective for keeping this under control. All right, I'm going to turn it over to Steve Rettke.
Okay, thank you, Bill. Good to see many of you back again, all the regular participants. And I'm the middleman of this trio we have of presenters. And so today I'm going to speak on the azalea leaf miner, a couple caterpillars, and the mimosa webworm, another caterpillar. Also going to speak on some mites, the Errickson mites that specifically we see on leaves, and their plant leaf galls. But I wanted to start off with something more of an abiotic concern, which I think many of you have seen on various spruces, and particularly is most pronounced on the Colorado blue spruce because of that blue glaucous bloom. And so it's an interneedle discoloration that's caused by potentially a couple different reasons, or a few different reasons, but let's talk about a few of those. All right, and there's the photograph of actually a container of a Colorado blue spruce, and you see how the outer newer growth is a nice blue glaucous bloom coloration to them, and the inner growth has lost that. And what's the reason? What's going on there? Well, it can occur on both white and Colorado spruce occasionally, but I don't see it quite nearly as often. It's not as obvious either on Norway spruce. But that, by the way, that blue glaucous bloom is important for Colorado blue spruce. That's where is it native from? The Rocky Mountain areas, and so you have your dry winter winds, frozen soils, and to avoid at least reduce desiccation from the needles, they produce this waxy bloom, which is known as, I keep saying, the blue glaucous bloom. All right. And why is this happening then? And why is the inner needles losing that more characteristic or aesthetically pleasing look? Unless you like that variegated look, I don't know of many people who do, but anyway, it's not usually one that people want. And so what's going on is, well, it could be a couple different reasons. One could be simply maybe you made an error and sprayed a dormant horticultural oil on the needles before the new growth occurred, and then you dissolve that waxy bloom, and then the new growth comes out and it looks nice and normal again, but so you have that two-tone coloration to it. Another thing, and maybe spruce spider mites were feeding on it, and they are stippling, they're removing the cell contents and causes more of a chlorotic look. And they feed in the spring as the spruce spider mites or cool season mites. And so when the new growth comes out, they're kind of slowing down and they don't have a chance to really get to the new growth so much. And so that looks normal during the summer, but the stippling damage you see from last year's growth. So what is maybe what I think is most likely causing these, and I've seen it certainly a whole lot in landscapes, certainly in Christmas tree farms, and that is where you have areas where the soils are excessively wet. You know, you have wet feet, and it's maybe a low-lying area, or some areas that have a high percent clay, and so the drainage is slow. And so what's going on is that because of the lower oxygen for the roots, they can't translocate certain elements or minerals through the plant cell membranes, and that requires oxygen. And so materials, elements like potassium, for example, which is an important element to produce that blue glaucous bloom, it can't be absorbed by the roots because there's not enough oxygen there in the soils. And so what the plant does to compensate, the new growth is coming out, they need the potassium and it's limited, so they start to rob from previous year's growth. And so that's why that discoloration starts to occur, because the potassium is being translocated from the old growth in the previous year to the new growth, and they take priority. The new growth is most important to the plant, and so that's what's going on here. And so there's really another good example. That's actually at a Christmas tree farm. You see that real two-tone coloration. That happens to be a low-lying area at a farm that I've been monitoring for years. And the same sites every year get the same problems. And some cases, they make an attempt to renovate those areas. But that's a lot of time and expense to do that, to try to improve the drainage and maybe reduce the amount of clay that's in the soil. So I pretty much talked about all this already. And so, does that new growth the older growth, does it eventually come back? Well, it's limited because this translocation of potassium, it could be magnesium, could be involved as well, but it's primarily potassium generally. And it doesn't always have to be just wet soils. It could be actually excessively dry soils. Anytime the roots are compromised, you can have this situation occurring with this two-tone coloration. And so, the potassium does not really translocate well back to the older growth. It most likely just wants to move to the newer outer growth. And so once you get that two-tone coloration, all you're going to hopefully do is try to have maybe a good 2, or probably even better, to have 3 years of good growth where you have that nice blue glaucous bloom, and then the plants will look better and maybe more saleable. And then finishing up here, I think, well, I got one more slide after this, but this showing you where you have the upper 2 slides there on more on the left side. You've got the poor, slow drainage, and see that yellow chlorotic appearance to it. Not really a very pleasing, aesthetically pleasing look at all. And then in the one in the top center, that was actually a nursery within containers, a container bay. And you look at that, that really unattractive look that's showing there, the variegated two-tone look, and the grower there indicated to me, yes, they definitely over irrigated that, and so even though it was a soilless media, you can still over irrigate soilless media, and so you started, especially at critical time when the new growth is coming out, that's what's apparently happening. And then just showing at the bottom left, you do have the spider mites, not on a spruce, by the way, that's on a Fraser fir. You can see that discoloration of the stippling, whereas the new growth came out, but the mites really didn't have time to feed on the new growth because it was getting warmer and they were shutting down, as they don't like the warmer temperatures. They're cool season mites. And so they'll come back in the fall and then start feeding on that new outer growth. Okay, and then showing you the desirable color, this happens to be at a Christmas tree farm that was kind of at a hillside, and it was up more toward the tops of the hill, excellent drainage. That blue color was uniform throughout multiple years, and that's the ideal thing you really want to strive for if you're going to be selling Christmas trees, and especially a Colorado blue spruce, because it takes so long to grow. It could take 8, 9 more years for it to reach desirable height and to have the selling occur. And so as far as management, you can't add really usually potassium to the soil because it's really not a potassium problem. I mean, it's conceivable your potassium is low in the soils, and that does occur. Potassium does leach to a degree, but nowhere near as readily as nitrogen. And so much more often is the case, you just have a root stress taking place. With the fact that the oxygen is just simply too low. And if you, especially if you start seeing that two-tone coloration and you start using nitrogen fertilizer, you're going to make the problem worse more than likely. And so to try to solve the problem and improve the drainage, it's not an easy thing to do. Usually it's a low-lying area. So really what you want to do as a Christmas tree farm, you want to take the time when you're first planting the farm to make sure you're planting the species in the right sites and choose those areas carefully. Learn what species and what type of conditions they grow better in, and knowing that the Colorado blue spruce really doesn't like the wet soils on their feet all the time. Yeah. All right, so let's talk about the first of two different types of caterpillars. And this is one that, in the landscape, I don't think when I worked in the landscape business industry in the 1980s, I don't think I ever really noticed this. I know it was there, but it never caught my attention. But in the nurseries, and especially container nurseries, it's a different story. And this is the azalea leaf miner. It is a caterpillar, and they feed exclusively only on azaleas, and so it's definitely host specific. And the signs and symptoms are rather subtle, and it can even easily be overlooked unless you know what to look for. And the photograph there is a good one showing you 3 leaf miners. You can see the more blotched or elongated leaf mining that took place. That's being done by the earlier instar caterpillars. But once they reach a certain size, maybe like mid-instar stage, they're too big and they can't feed inside the leaf between the upper and lower epidermis of the leaf any longer. So they come out and they emerge and they go to the tips. Usually it's the tip of the plant. And then what they do is they, like a blanket on a bed, they fold the leaf over using silk. They fold it over themselves for protection, and then they can resume feeding, and then that's eventually where they'll pupate and emerge as adults. So the leaf miner stage is usually less noticeable, and many people don't even see it. It's only when you get that leaf roller stage, and certainly the symptoms become far more obvious. There are 2 generations per year as shown, and at this time, we are now having, the first generation has concluded. The adults have already come out. They mostly came out primarily in mid to late June, and certainly by early July, and maybe northern New Jersey, they're still potentially emerging as adults, but the adults will begin to lay eggs. They'll mate and lay eggs in the bottom of the leaf near the mid vein, and they lay either 1 or 5 eggs. And so that's why you can have multiple leaf miner stages. And so it's typical that I see 2, 3, or more leaf miner stages. But what's curious is that you're going to only have on one leaf, you're going to always only have 1 leaf roller stage. And if you have more of these caterpillars coming out as from the leaf miner stage, they got to go someplace else because that's already occupied. So apparently they have this contract that they agreed to. And so the ones that didn't form the leaf roller stage first, they then go to another leaf. And so sometimes you'll have a leaf with only the leaf roller stage with no leaf miners. And so that seems strange, but yeah, they just have to move over to another leaf and they form that leaf roller stage. All right, so, the second generation is now just beginning to probably hatch, and the leaf miners are starting to be formed. You start to see the blotches, and this is the ideal time to control them. And so you'd have to use some type of systemic or translaminar type material. You could attempt to go after the adults with contacts, but that is kind of a difficult one to achieve. You have to get really good timing for that. But some have shown success with going after the adults. But now, especially in South Jersey, I think the adults have all emerged and probably laid their eggs. And then now you've, for the most part, and then they're going to start to see those leaf miner stages. And there's the adult there. It's not very large. It kind of has a brown, drab coloration to it. It's less than maybe 3/8 of an inch in size. You can monitor for them by shaking the azaleas at certain times of the year. So say in central Jersey, I would have started shaking the azalea plants. If you had that first generation and you notice the symptoms with the leaf miners and the leaf rollers, you can shake the plants to see if you have adults that are active. And they'll kind of flutter up for briefly, and they'll go back down into the plant. So that gives you maybe an idea of what the populations and the amount of eggs that will be present. And so anyway, let's see what else we have to say here. So the second generation is now beginning, and so you really want to go after that leaf miner stage, and they will get pretty good size when they reach that leaf roller stage. And I think I have photographs of that. And just to finish up with some of these subtle symptoms, you notice there's the leaf miner at the top. You see the arrow, red arrow pointing to the leaf miner. Very easily overlooked, but then the leaf roller stage is a little more obvious. And then kind of going counterclockwise, you see both the leaf miner stage there on the bottom left, and then you have the leaf roller stage. And then you go up to the top center, you can take that leaf that's been pulled up over itself. They use silk to do that, and then the caterpillars continue to grow and develop. But you can turn it over and you can expose the caterpillar, and there's that red circle there shown at the top center. You can see it. So they get to size up a little bit, and that one's getting probably pretty close to pupating. And just to show you that in some cases you only have leaf roller stages, that bottom center, there's no leaf miners there, and so those leaf rollers came from another leaf where they fed as leaf miners. So they can have that ability to move around from one leaf to another. And then sometimes when you remove the tissue and you uncurl it, and you see they're gone. And so they've already pupated, they already left as adults, and all you have left is the frass. And so you've missed the window of opportunity, at least for that immature stages. And so for controls, key thing again is to remember to try to control the leaf miners during that stage. Far easier to control those than the leaf roller stage. But you can get control during the leaf roller as well. But you have the contacts with the contacts shown there, and some of those contacts are actually also systemic or at least translaminar. And so you can get control with those materials against the adults if you get the right timing. Neonicotinoids all work well. Imidacloprid, acetamiprid, which is actually a biorational neonicotinoid, and then acephate, the old standby organophosphate, which is a translaminar. Love the smell of orthene in the morning, which is a type of a brand name for acephate. And then some of the biorationals, oils again soaps will be contact only. Azadirachtin has some systemic abilities, mostly translaminar, and then same with spinosad. And I've already mentioned acetamiprid. Okay, and so let's move on to the next pest. And it's not an insect, it's a mite, and these are the Errickson mites, and these are really curious, and they have a unique colors to them at times, and they have a really unusual shapes with these galls, and they can be bladders or spindles or rhiniums. I'll talk about what I mean by that. And what's happening here is you have the mites, and this is one that really occurs early. I don't have any growing degree days listed for this because it's really, for control window is right before the buds begin to either swell or at least just as they're breaking. That's kind of your very precise window for treatments, and you have to use with a contact miticide to get under control with these materials. And so what happens is that when these mites are either laying eggs or they start to feed, they release toxins or foreign chemicals. It causes a release of chemicals, as I stated, that creates an accelerated abnormal growth. It's an undifferentiated type tissue growth that will often, maybe in some cases, surround the eggs, the Errickson mite eggs. And of course, you remember Errickson mites are smaller than spider mites. Spider mites are 1/50 of an inch. The Errickson mites are half that size or even a third of that size. And so they're really tiny, tiny creatures. And they can, you see those maple bladder galls there, that nice colorful formation. It's not really a health threat of any kind, but for nurseries and you're trying to sell plants, maybe some people might object. And so, but they're very difficult to control. And once they're in that stage, that gall stage, I think any types of controls is really too late. You're not going to get any kind of systemic moving into that undifferentiated tissue gall that's been created by it. And an interesting thing is that these galls and this accelerated growth, that early research by scientists was they did with this particular types of galls and other galls as well for cancer research and what's going on with this accelerated plant tissue growth. they thought they might gain some insights with cancer research. So, but they're not really harmful to the plant so much, except if you're trying to sell them in their extreme. All right, so let's take a look real quick. So that's a leaf gall on a willow leaf, and that is something that seems to be real common. This happens to be a container, and look at the extensive galls that are happening there. All right, and that's extreme in that case. And so you might actually have a point where that might be a difficult plant to sell. And I have seen extreme infestations on some of the willow leaves at nurseries I've monitored. And then kind of a real curious one is the erinium gall mites. This happens to be on the right-hand side. That's the silver maple. And what's going on here, you got these foreign introduced toxins that are causing a real just plant hairs that are really dense, almost like a what's the word? Just an abnormal amount of proliferation of plant hair growth, and it gives them really excellent protection for the mites to be down in there. It's interesting looking at these erinium mites under even just a hand lens, 16x hand lens. You see some interesting things at that, even with that relatively low magnification, but that coloration is really distinct. If you look at that, he says, oh, it's got to be a fungus infection. But no, it was from an erinium mites, from area 5 type mites. Okay. And as far as management here, again, you really have such a precise window. In the landscape, I don't think I would ever recommend anyone attempting to try to control these. Oftentimes in the landscape, or even in field nurseries, you might have some of these gall mites present, and then the next year they're gone. They don't even come back. And so it's really just an aesthetic concern and more of a curiosity than anything else. And so that bud swell or bud break area of window control is really, really small. It could be really less than just a few days in many cases. And so it's not an easy thing to achieve. I did have a nursery that attempted to do the control. It was a nursery that actually had those willow leaves I showed the picture of. And they reached out and they said, what can we do to control these? And they made the attempt to control them in the spring, but their results were, as I remember, was somewhat limited. So those are some of the contact materials that are listed there: oils and soaps, abamectin, carbaryl. Carbaryl actually is a miticide for area 5 mites, which is certainly not the case with spider mites, but have acephate and neem oil as well. So those are spindle galls. If you cut one of those galls open, you would see many, many dozens and dozens, maybe well over 100 of these area 5 mites feeding in this hollow gall that's present there. All right, so I finish up here. I think this is my last one because I'm almost out of time already, as usual. I'm just awful with time management, but this is the mimosa webworm, and it has 2 generations per year. And it's called mimosa webworm, but however, there's not a lot of mimosas, nearly as many as we have honey locust trees, and so I more often find them on honey locust. I don't think that I've ever seen mimosas being sold in nurseries. Others, as you can see, they have a nice flower this time of year, but they have a very short life. Mimosa, they typically within 20 years they get killed by a soil pathogen. Fusarium, I think, is typically takes them out. So they're a very short-lived tree. But this mimosa webworm, of course, it's a caterpillar, and they overwinter, really interesting, as pupae and as cocoons in bark flaps. And I've seen them most often, as I say, in honey locusts or in the cracks of the trunks of the trees. You might see them on the lower scaffold branches as well. And these cocoons, if they're really a high population, they look like puffed rice. And they kind of come out and hatch. You can see the 2 generations, and they're growing to retain rages. And so right now we're still really mostly in fact we're totally only in the 1st generation larvae caterpillars that are feeding in the mimosa, rather in the honey locust or mimosa, and they're feeding in the leaflets, because mimosa and honey locust both have compound leaves. And so when they emerge, you can look for them, but you'll probably never see them come out as adults because the adults are nocturnal. They're moths and they want to try to avoid predation, so they come out at night. But they emerge as adults in June, as they're overwintering sites. And the very first instars are tiny. They're only about 1/12 of an inch or 2 millimeters long, and they etch the undersides of the leaves. They often form back-to-back leaves. They put the leaflets together and they feed in between the leaves. So maybe like a leaf tier type of a feeding pattern. but they do reach much larger sizes as they become mature caterpillars. But there's the adult that came out. The second generation is going to be coming out and really begin to lay eggs kind of the very end of the month of July, and then also in August. But right now, that first generation is still a larvae, and they're still developing, and the adults haven't come out yet for the second generation. So, all right, so there's the adult moth cocoons that emerged from the overwintering. And there's those brown pupal cases, and all right, so let's see. The first generation feeds in July. Okay, the second generation is going to be mostly we're in August and September. And what's kind of insidious about this particular type of webworm caterpillar is that the first generation maybe often is not noticed so much, but it's the second generation that what they do is the adults that come out from that first generation that emerged and matured and became adults, they then lay their eggs right in the same locations where they were feeding previously. And so that second generation now expands and makes the feeding area even more noticeable and become much more pronounced as far as damage. In fact, in some cases, by the time you get into September, it looks like the tree has been scorched by fire if you've had a really extreme infestation. And so, all right, so I got to finish up real quick here. This is showing you the various stages there. There's that first instar, 2 millimeters. You can see that metric is 2 millimeters, quite tiny. Then the next one to the right, you got the third instar, which is to the right of the sixth instar. They really size up to be pretty good size. And by the time they get to those later instars, they're not just etching the undersides of leaflets. They're skeletonizing or consuming entire leaves, or at least the leaflets. And then you see the webbing of the leaflets. That's now the population's really starting to build up. And then just to finish up with the feed etchings there on the leaf undersides in the bottom left. And then there's an extreme population on the far right of the overwintering cocoons, the largest population I have ever seen. It was at a median strip next to 2 parking lots. You had this honey locust growing there. I think it survived well because in the wintertime, they're not very tolerant of colder temperatures. You go up a little further up north into New York State or New England, you'll have much reduced populations of mimosa webworm. They can't tolerate the colder winters, but the fact that it was near these paved areas, the winter sun, it kind of heated them up, and they were able to survive a better case and more readily. And then you have the brown pupation skins there at more at the bottom right. All right, so the final slide, just showing you some of the controls. This is a non-native caterpillar, but yet we still have a lot of predators. And normally with native caterpillars, there's a lot of predators and parasitoids that keep them in check. Well, this is an example, maybe a little bit of exception to the rule, where we have a non-native caterpillar, and we have a lot of predation and beneficials, things like parasitoids, predaceous stink bugs, assassin bugs, green lacewings. In fact, there's a close-up photograph there of an assassin bug. I took this photograph and I dug it out. Actually, it fell out of this honey locust branch where it was loaded with the mimosa webworm, and there this thing comes walking out, and once it's picture taken, and so I said, okay, I'll take your picture, and there it was, had no fear of me, and I said, thank you very much. And so a nice photograph he allowed me to have, or he or it, okay, and then showing the contact insecticides again, the systemics, and just remember that if you really want to prevent that second generation, which causes the most apparent damage, control that first generation. And then you have BT, of course, works well, but that's really a good thing only against the younger instars. Once they get that thick webbing, it's not going to get those protein crystals, because remember, that's a protein, a stomach poison, it's an endotoxin. And so the caterpillars must consume it before they are killed. And so I'll leave it at that. And so, as usual, let me hand the baton over to our anchor man, who is Tim Waller, and he will bring us home.
All right, well, hey everyone. So today I wanted to touch base on a couple of problems that we start to see this time of year. As we've talked throughout this talk, sometimes we start to see symptom development and something has occurred much earlier on. Kind of similar to the interior needle discoloration. When we have root diseases that are occurring in plants, we start to see a whole lot of things happening. Generally, we can see things like chlorosis, particularly interveinal chlorosis. Sometimes we'll see wilting, other times we'll see leaf drop. And all these things really come down to the fact that the plant is not able to pull up the moisture nor the nutrients that it needs during the height of the season, which can be a very stressful time for a lot of our plants. Depending on what we're talking about, in the case of conifers, they're doing a much less growth during this period. They're kind of just hanging on versus our other broadleaves, and definitely with our more herbaceous stuff, they're actively growing and they need a lot of resources. So that's why we start to see these really interesting symptom developments as we go throughout this. All right, so I just wanted to do a couple pictures here. There's so much more that goes into all of these different components, and if it's something that is happening at your nursery, farm, what have you, I'd be more than happy to talk with you about this. So we do a lot of programming with the group, particularly the Oomycetes, things like Phytophthora and Pythium. But I wanted to go with some generalities. We're going to do 2 slides of conifers versus broadleaf, and then some other things to think about, which kind of dovetails from our last conversation talking about how we kind of work through phytotoxicity issues. So in the case of conifers, we all know that when you're driving by a house and you start to see a yellowing discoloration, that something's going on in there. But there's a couple more things that I wanted to really bring home the point that can help us discern whether or not we have a nutrient issue or maybe we've got a phytotoxicity issue. In the case with conifers, and I've seen this over and over and over again, is we can have plants that are discolored, but if we look at their new growth, it's the correct size. It's growing just like it's perfectly green or whatever color it's supposed to be counterpart. However, in the cases where I've gotten positive hits for root diseases, oftentimes that new growth is greatly stunted. So we've got discoloration plus stunting. Something else that's not just with conifers, but a lot of times with our root diseases, we'll start to see flagging or areas of the plant that I like to call it zone death. A particular area of the plant is really starting to die off. We need to get in there and take a better look at that plant. This includes popping it up, taking a look at the root systems, but also the above ground symptoms. We need to check for, are there any damages? Do we have any pests coming in? And if we're seeing discoloration in the roots and this flagging appearance, again, we're probably dealing with a root disease. And what's really happening here is that these plants they didn't get enough nutrients or moisture during the early parts of the year, and now they're really starting to show their symptoms. Something to keep in mind too when it comes to conifers. So we've got plenty of needle cast diseases. In the needle cast situation, we have a pathogen that is triggering that plant to abscise those leaves. That's the needle drop component. In many of our root diseases, though, we can have apparently rapid plant death, and they're going to hold on to those needles. So if you have plants that are very much on their way out and they still have all their needles attached, that's something to keep in mind of. All right, next I just want to talk about a couple things with broadleaves. I'm sure we have unfortunately seen before with rhododendrons where we have something like Phytophthora cinnamomi that gets into a planting, and we're starting to see this rapid leaf curl. We've got stunted new growth, we've got yellowing, and in the case of many of our broadleaves, we're starting to really see those leaves curl up. In other plants like boxwood, ilex, the zone death can be extremely pronounced. In the case of something like boxwood, we could have a plant that looks very similar to this image that could be caused by something like Voluatella, or if, say it was a boxwood and all those leaves had been cast from the plant, and now we're looking at something like boxwood blight. But zone death is a very common thing. And again, we just need to make sure we're checking to see if there's any damages or mechanical issues that could cause this. If we're not seeing this, it's the height of summer and we're seeing parts of the plants die out, we're probably dealing with the root disease. And then I just wanted to bring up this image here of this interveinal chlorosis. This can absolutely be a sign of whether it's something like Phytophthora pythium or something like Flaviopsis or black root rot. This is definitely a symptom that we can see this time of year in our plantings. The other consideration here, though, is that I have seen many instances where plants with this interveinal chlorosis had just been heavily fertilized. Maybe it was with a granular, and it appears as though those roots were actually burned because I've gone through and I tried sampling for pathogens and didn't find any. So it's always something to keep in mind this time of year, especially with the extreme heats that periods of heat that we've had, relatively early in this season. So just some other things to look out for. If you've walked a nursery with me before, you know that it's all about asking questions and we're trying to figure out what could be going on here. So I'm kind of going to go reverse order on this slide. One thing that I have noticed with many root diseases is because the vasculature, of which we're going to talk a little bit more about vascular next week or next time around, these plants simply don't have enough resources to sustain the growth that they have. And I have seen many iterations of plants trying to regrow. That part dies off. It doesn't have enough resources. A new part begins to grow. So these repeated attempts at regrowth can be a great indicator that you're dealing with a root disease. If you've got multiple plants that are all roughly the same size compared to other plants that are the size of which we think they should be at, again, this is an instance where you really should be working with a diagnostic lab or trying to do some more diagnostic activity to figure out, are you dealing with a root disease? Was there a miss in a fertilization? Or are we potentially dealing with some issues with irrigation? So dispersal pattern matters. So when I was talking about phytotoxicity, one of the main things I have to figure out when I'm looking at plants with problems is what is the dispersal pattern? If all of the plants in the image above here had that same brown discoloration, we would really start to think, are we dealing with phytotoxicity? However, we've got this sporadic growth, doesn't seem to be on the edge, doesn't seem to be in the middle. So again, this is a great case to really take a deeper dive and look for root diseases. All right, so I'm going to switch gears a little bit. I'm going to go a little quicker through this because I don't want to keep you all too much longer, and I appreciate y'all's time. But I wanted to talk quickly about calibrating, nozzle selection, but really I wanted to have this section here so I could share resources with you that I have found to be really important. So calibrating, basically the name of the game is we're making the chemicals that we're purchasing, we're making them work for us. We're getting the right doses down. We are getting the right dose that does not push resistance. Sublethal doses with a lot of insects can be more problematic. It's costing us money and we're still not getting the control. And we also don't want to cause phytotoxicity. Spray uniformity is also something that's really important. So if we think about our sprayer and one of our nozzles is all gummed up, and we're talking about this world of we've got all kinds of different pests that can hide in all these different locations, or pathogens where one propagal could lead to 1,000 spores, spray uniformity is really important. And it's something that should be checked throughout the season to make sure that the equipment that you're paying good money for is working for you. And just a couple more things to kind of drive home this point. This is something that is very common to all of our operations, whether that's Christmas trees, that's landscapes, nurseries, in the greenhouse. Where we are, the physical location that we are spraying our plants from really should dictate how we go about doing our sprays. So in this example here, if we can just imagine we're trying to fight something like juniper tip blight, and we are getting a very low dose on that farthest away area, where would we expect to see the highest propensity of this particular disease? Of course, it would be in that area that's getting the least amount of spray. Where would we expect to potentially see phytotoxicity? That's where the plants are getting hammered with the materials. So this really can come into play as well. And this is something that I'm working on and trying to get some more resources together for, but just checking where your spray is actually going. If you're using something like chlorothalonil or something like a copper that has a physical appearance to it, you can check and see where that material is actually getting to. Yes, that's nowhere near as good as these water activated or moisture activated spray pavers, but it does give you an idea of where that material is getting to. So if we look at this image here and we think about controlling scale insects or think about controlling mealybugs, and we are not getting penetration into the canopy where we really need to be affecting these organisms, it really makes you question why we're using the materials in the first place. So it's really making sure that the materials we spend good money on are most effective. So I wanted to share this resource. Really, it was the crux of this slide here, Sprayers 101. Not affiliated, really great resource. Goes into all kinds of extremely large sprayers, all the way to very small sprayers. Really cool information, and I highly suggest it's really worth a read and looking through that. But really, we're checking our speed. We're in communication with the manufacturer of our sprayers, checking air direction. This Sprayer 101 has some really cool tips about how to check the canopy penetration and angles off the various forms of sprayers that we're using, and just really calculating the amount of output, our speed, and how much of that material is getting into the plant and at what amounts can be really impactful to make these materials work for us. So related to spraying is this concept of chemigation. We all have, in the nursery side, we all have irrigation set up in Christmas tree outfits. There is some movement towards drip irrigation. I think that movement will increase if we continue to experience prolonged time frames of drought. I know we've gotten a lot of rain so far, but if we look back at the last 10 years, you can see why people are moving towards drought. So I wanted to share this concept, this resource here of using chemigation through our irrigation systems. This is highly dependent on the chemical bottle that you are holding in your hand and what that label says. But I just wanted to include this because, yes, this particular article is for vegetables, but the concept is really well put together. And this is from North Carolina State University. And basically with chemigation, yeah, there's setup costs. We need to make sure that we are not pumping pesticides into our wells, into our drinking water, into our buildings. And there are things to be considered before we get into chemigation. And we really do want to take this seriously. And not every material is going to work for us. With our insecticides, there are many materials. With our insecticides, systemics are really what we're after here. We've got neonics, diamides, and some other materials. When it comes to systemic fungicides, if we think about pumping something like chlorothalonil that's super chalky through our irrigation system, whether that's drip or above, we can see how that'll have problems with our emitters, cause a lot of clogging, and overall could kind of be a mess. A good candidate for this material are the phosphonates. You hear me talk about these all the time when it comes to suppressing things like Phytophthora and Pythium. But this particular group of materials does have impact on many other plant pathogens as well. Also, our group 11 and our group 3 materials often find themselves with chemigation labels. Again, making sure that the labels are clearly dictating that you can use this in this setup. Really, this is the last resource I wanted to share with everyone. Ag spray nozzles. It's through Purdue. This is such a cool document. If you are at all involved with your sprayer components, whether it's in your air blast to your spot and spray, etc., this is a really, really cool document that I feel lays out a lot of this really dense information in a nice, comprehensive way. And one of the big things that they talk about are when to use different types of nozzles. If we have, so that we take the image all the way on the left, I guess it's the one that says 33%. In this case, if we're thinking about the different types of materials that we have, this would be a great application for a contact material. We're getting a lot of coverage. If we've got something that's translaminar in nature, we can get more into the 4 to 3 to 1% of that spray paper being covered. All of this nozzle selection, though, is balanced against drift management. If we've got these superfine droplets, but they never actually hit the plant that we're spending money to control a pest on, then we need to select a better nozzle for the application. And TJet also has some really good information. This isn't a plug for them, but they do a really good job at putting together a lot of really useful information to help us in the field select better materials. All of the nozzles have different characteristics. Some are air injected, some are better for contacts, others are better for systemics. And they give a lot of really good information on spacing if you're kind of doing something that's a little more outside the box for your particular application. And again, it goes into all kinds of different nozzles. Strainers are very important depending on what we're using. Some strainers have no drip components to them. In some cases, you want a no drip strainer. Other cases, you don't want a no drip strainer. You want a diaphragm to stop the sprayers from dripping. This goes into all of that. And it's a really great resource. Again, not affiliated, but this is something that you really should check out. And this is my last slide or two here, but I just wanted to make a plug personally for heat stress in agriculture. We all know that it's a contentious issue right now in agriculture in New Jersey and throughout the United States. But I want to implore to everyone that taking heat stress is important. Taking heat stress seriously really is important. Like that little note says, I cracked my head open after spraying in cranberry bogs one day. I had a Tyvek suit on. It was roughly 120 degrees in my suit. Point being is that we're all people, and taking this seriously is really important. And a plug here too is if you're going out to spray in these conditions, many of our compounds can be phytotoxic when we're getting to 90+ degrees Fahrenheit. They can be really impactful on flowers. They can cause all kinds of weird tip burn, or they can cause little bits of damage that could be colonized later by something like botrytis. And luckily for us, in these really hot periods, a lot of our pests and pathogens are in a level of dormancy during the height of these heat waves. All right, so thank you very much for attending. We've got a number of topics lined up for next week. But with that, I really want to say from all of us, thank you as always for attending, but we are very much open to new topics and ideas. So the early part of these sessions have very much been, we have a lot of pests coming on. There's a lot of things we need to talk about in a quick time frame. However, if there's something that you want us to talk about, whether that be a pest, a disease, a topic, an approach to how to deal with something, we're very much open to ideas, and we'll do our very best to incorporate them into these lectures. So with that, I'd just like to say thank you very much to everyone, and I believe we could end the recording.